Now I would like to introduce our second speaker, Dr. Kobi Lasri, who is General Manager at Ophir Optics.
Thank you very much, John, for the introduction. It's really a pleasure to be here and to be talking about advanced optical solutions for security and defense applications. So let's get going with the outline of the presentation. In the first part, I will give a short description of the optical solution business of MKS, followed by an overview on the key defense and security trends and application drivers, and actually follow the presentation by John, the previous presentation. In this presentation, we will focus on trends related to optical solutions, and also we will describe the considerations with respect to long-range surveillance solutions using advanced thermal imaging zoom lenses. This is basically going to be a relatively short 15 minutes presentation, so let's try to make the most out of our time together. So please take notes, and if you have any questions, I encourage you to enter them into the question box, and I'll do my best to address them at the end of the roundtable presentations. So let's start with a brief overview of the optical solutions business of MKS. John really described the company MKS. So within MKS, we have a global presence with 7 sites worldwide just related to optical solutions with 800 employees, which really makes it one of the largest optics companies with advanced design and manufacturing capabilities of both optical components and assemblies, from deep UV to far infrared wavelength solutions. And we basically provide high precision optical solutions for various markets. And let's focus on the security and defense needs. So basically, Ophir Optics is providing mainly high precision infrared solutions that are vital in advanced defense and security applications. In fact, there is virtually no part of a modern defense and security system that is not impacted by high precision optics. The ability of the defense and security sectors to leverage light sources and also light detection is imperative to ensuring our safety and quality of life. And this includes airborne, land, handheld thermal imaging, and naval defense applications. In security, it includes surveillance, border control, and also 24/7 infrastructure security. So let's now review the key defense and security trends. We're starting first of all with the worldwide increased defense spending. Global military spending growth has accelerated in recent years, and this is a major driver for emerging technologies. In addition, the proliferation of unmanned aerial vehicles, we're talking about security and surveillance, homeland security, border control, and also this includes all these trends, including the drones, UAVs. They require reduced size, weight, and power. This is what's called low SWaP, and also increased operational ranges. And we are seeing more and more demand for solutions for the growing trend of drones and UAVs. There's also a growing demand for complex intelligence, persistent surveillance, and target acquisitions, and we are talking about the need for capabilities, multispectral imaging, also day and night long-range surveillance, so longer and longer ranges for persistent surveillance applications. And following the presentation of John, the growth in laser weapons that is mainly driven by recent advances in high-power laser technologies, with power levels exceeding 10 kilowatt, and also laser measurements that John presented in the previous presentation. So this is really an additional growing trend. So let's look at the end-to-end optical solutions. High-end optical solutions that address the recent trends include both high-precision optical components and also complex optical assemblies with state-of-the-art design and manufacturing capabilities. So it's really crucial to have the capabilities, vertically integrated capabilities, starting from the ability to manufacture high-precision components, different sizes, and integrate them in complex assemblies that are needed in various defense and security applications. Before we dive into various applications, let's just review the key highlights of thermal imaging. That is one of the key technologies used for defense and security applications using optical solutions. In the upper left side of the slide, you can see the portion of the electromagnetic spectrum that is relevant to thermal imaging. All objects at temperatures above absolute zero emit infrared radiation in the 3 to 14 micron wavelength regime, which is comprised from the mid-wave infrared and also the long-wave infrared portions. The higher the temperature of an object, the higher the spectral radiant energy or emittance. In the upper right side of the slide, you can see the well-known representation of thermal imaging camera that basically captures the emitted radiation from an object and converts it into a visible image. So now let's see how we can use this technology for various applications, starting with advanced infrared optical assemblies for defense applications that are based on thermal imaging technologies. And the infrared optical solutions should basically meet the challenging defense requirements, and this includes high precision swap optimization. Just to remind you, swap is the requirement for low size, weight, and power, ruggedized design, outstanding detection, recognition, and identification ranges, accurate line of sight, and also a military standard spec, especially requirements to meet the harsh environmental conditions. If we look, for example, the applications airborne, where both lightweight and long-range zoom lenses are used in surveillance and also intelligence in constrained platforms and also harsh environmental conditions. Land applications, for example, with like thermal weapon sights and handheld thermal imaging systems. In naval, thermal imaging lenses are extensively used for navigation, collision avoidance, and search and rescue missions. And also, we have also missiles applications for thermal imaging guiding systems. So we basically provide and need to provide different solutions, not only components, but here you can see different zoom lenses, lightweight and long-range zoom lenses for different applications, different defense applications. In the defense, there is also a need for in many cases for high precision optical components, just in the component level, not only in complex assembly level. Such components are also vital in advanced defense applications, and we are talking about, for example, large high precision mirrors, lenses, windows, and prisms, domes for advanced missiles. We need to support multispectral optics capabilities and emerging applications. Wavelengths that range from usually visible and infrared, in mid-infrared to long-infrared wavelength regimes, high power coating capabilities, for example, for laser weapons, spherical, aspheric, diffractive, flat, and freeform shapes in the components level. And again, all of such components, they need to meet middle standard specifications. Also in the security applications, we need to meet requirements mainly for a long-range application, high-precision optics, swap, outstanding DRI ranges, again, durability in harsh environmental conditions. And here we are talking about, for example, homeland security, border control, perimeter security, maritime application, aerial, again, the growing trend of drones with respect to lightweight zoom lenses or components, and also long-range solutions, and some of them are described here. Let's look at some key considerations for long-range surveillance lenses for both security and defense applications. Here's a basic schematic. Here you can see a thermal imaging camera that is comprised of an infrared lens assembly that captures the infrared radiation emitted from an object in a scene, and it projects it onto a detector array that converts it into a visible image. In order to determine the lens specifications, we need to address the overall system requirements, including the detection, recognition, and identification requirements, whether we need uncooled long-wave solutions or cooled mid-wave infrared solutions. Resolution and detector type is really crucial for determining the specification and performance of the lens solution, including width and height in pixels, the pixel size. This is basically the format of the array, and also the lens focal length and F number. Sometimes there's a compromise between the two, of course, size and weight. The optical performance determined by the modulation transfer function requirements of the lens, and of course, environmental requirements should also be addressed. Let's, for example, review how we implement such considerations in most recent infrared zoom lens solutions. For example, here in this slide, we see long-range zoom lenses for cool detectors that are the most sensitive class on the market today and operate in the mid-wave infrared wavelength regime. Such a band has a greater atmospheric transmission than long-wave infrared in most climates, and therefore such lenses are most suitable for longer range applications. The focal length basically determines the field of view of the thermal imaging camera, and therefore the DRI detection, recognition, and identification capabilities. Basically, the longer the focal length is, the smaller the field of view, which translates into more pixels across a target at a fixed range. For example, based on the well-known Johnson criteria for identification, we need more than 8 pixels across a target to identify a man. So we need to calculate the target angle based on the target dimensions and distance, and then divided by the field of view, which is determined by the detector pixel size and the effective focal length. And the large number of zoom lens options that we have with up to 1350 millimeter focal length basically enable state-of-the-art ranges of over 25 kilometers. This is really the longest state-of-the-art focal length solutions available by mid-wave zoom lenses. Here we can see a video that shows some of the capabilities. Actually, we saw just an example of one of our long-range zoom lenses. This is up to 850 millimeter. You could see how the zoom lens can keep really a fixed line of sight, very stable, with the ability to change the zoom location without actually impacting and affecting the line of sight. Very clear and sharp optical performance, and it's really crucial for advanced defense and security applications. So just to summarize, high-precision optical solutions are really vital in advanced defense and security applications. We are talking about thermal imaging, day and night vision, surveillance, missile guidance systems, and laser weapon applications. Advances in zoom lenses, they really play a key role in UAVs, and they open up new opportunities in advanced defense and security applications. We are talking about solutions that include lightweight zoom lenses with the highest level of optical performance over the entire zoom range. Also long-range focal length solutions with capabilities for high-resolution imaging in harsh environmental conditions. So thank you very much for attending this presentation.